Good afternoon, viewers at home. You are on to Mathematics with Dr. OJ. In this video, we shall look at some examples of tutorial questions on geometric progression. Please don't forget to subscribe to my video channel by clicking the subscribe button below the video. Thanks and God bless you. The sum of the first two terms of a geometric progression is P, and the sum of the last two terms is Q. If the geometric progression has n terms, find the common ratio. Unexpectedly, we are not given discrete values of the sum of terms here. We are just given abstract values like P and Q. So we are given variables there. So how do we now get the common ratio we are asked to find? So in other words, that means our common ratio will be in form of variables as well. So to do that, let us look at the solution. Okay? Now, we have been told that the GP has n terms. You have to take that into consideration. So the first two terms of a GP, we know that the first term is A, the second term is AR. You ask me how. Remember, the number of terms, nth term, that's Tn of a GP is AR raised by n minus 1. So if I write T2, when n is equals to 2, because we all know that A is the first term. So when n is equals to 2, we have A, that is AR, then 2, which is n, 2 minus 1. So that we've got R, because 2 minus 1 is 1, so AR. So the second term is AR. So with that statement now, A plus AR, according to that statement, A plus AR, according to the information given to us, is equal to P. Is P. So we can call this one equation 1, because this thing will look like equations, two equations there. We're going to form two equations from the way the question is framed. From the way the question is framed, we're going to have more than one equation. Okay? Now, and the sum of the last two terms is Q. Now, we know how do we find the last two terms. We know that the last term of an AP, the last term of an AP is still the same thing as, of a geometric progression is AR raised by n minus 1. The last term of a geometric progression is L is equals to AR raised by n minus 1. That is the last term. So we are told that we should have the last term to the last two terms. That means the preceding, the immediate past term before, or the penultimate term before the last term. So the penultimate term of GP is going to be, recall, the penultimate term, the penultimate, or the last but one term, the penultimate term of a GP is AR, raised to power n minus 2. Can you remember that? That is AR raised to power n minus 2. So the term before that one will be AR raised to power n minus 3. The term before that one will be AR raised to power n minus 4. So that, and so on and so on. So the R will be decreasing, So if you multiply this by another R, that will give us the last term. Yes. So that now implies that AR n raised by minus 2 plus AR n raised by minus 1 is equal to what? Is equal to Q. So that will form equation 2 according to the statements. According to the question. Okay. So with this, in this equation 2, we can, going back to equation 1, something is common there. So A is common. So in equation 1, in 1, we have A into 1 plus R is equals to P. Yes. If you factor A out here, you have left one here plus R. So that's still our equation 1, just that we have just rewritten it. Okay. Now the same thing can go for equation 2. Something is common there. AR raised by n minus 2 is common because this one is bigger than this. So AR n raised power minus 2 into, so what do we have? Let's say 1 plus, so what do we have left there? If we multiply this by r, it will give us this. So plus r is equals to q. I hope you understand. By the time you multiply out now, you get ar raised by minus 1 bar. So divide equation 1 by 2 or 2 by 1. It's still the same thing. So what we have? So we're going to have a into 1 plus r all over ar raised by n minus 2, into 1 plus r, then is equals to p all over q. So this one we cancel this one. A here, cancelling. So we are left with what? 1 all over r raised by n minus 2 is equal to p all over q. So now you can see that this is the reciprocal of r raised by n minus 2. So by the time we find the inverse of both, find the reciprocal of both, we're going to have what? R raised by n minus 2 will be equals to q all over p. I hope you understand. By finding the inverse of both. Now, how do we now get your r? Remember, the powers on r is n minus 2. That means we now find what? We find the n minus 2 roots of both sides. Okay? Find the n minus 2 roots of both sides. Find the n minus 2 roots of both sides. We have, or we get, that will be r is equal to r raised by n minus 2 raised by 1 all over n minus 2. That's what we are saying. Is equals to the n minus 2 square root of that q all over p. So this we cancel this. So when this one cancel this, we have what? R is equal to plus or minus n minus 2 roots of q all over p. So that solves the problem. So the ratio for that GP is this n minus 2 roots of q all over p. Please don't forget, subscribe to my video channel. God bless you.